Hello everyone, I am Ninu Francis, Assistant Professor in Computer Science and Engineering Department of Jyoti Engineering College, Cheruduruthi, and I welcome you all to our online learning platform. Now moving on to the topic, the RTOS design principles. Okay, we know that what is an RTOS? A real-time operating system. Okay, we have already said what is a real-time operating system. As the name implies, it has a real-time constraint. That is, it has a deadline, and it has applications in the hard real-time and soft real-time applications, and it has a time constraint. Okay, and we are moving to the advantages of using an RTOS. And if we are using an embedded system with a single CPU, it can run only one process at an instance. Okay, and this process can be either an interrupt service routine or an ordinary task or a kernel function. Okay, but in the case if you are using an RTOS, the thing is that we can run the user threads in the kernel space, and the advantage is that we can run very faster, so that the execution will be faster. And it also provides the effective handling of interrupt service routines, device drivers, interrupt service threads, or even task or threads. And there are some situations in which we need to run the interrupts in the user mode critical section code. Okay, in such situations, the RTOS, it can enable and disable such interrupts. And the next important advantage is that in the case of an RTOS, the memory management is very effective, because the memory is allocated and deallocated in the case of in fixed blocks or fixed partition of memory. It is allocated to the task on a need basis. Okay, so that is why we are saying that the memory allocation is done very effectively. And the next one is the effective scheduling of the task, and we have already discussed the certain scheduling models in the previous videos. Okay, and the next one is the use of mailboxes or pipes or sockets or any other devices also, and everything it becomes very simple, or the input output management becomes very simple by using an RTOS. And if we are using some shared resources, there should be some means of synchronization. Okay, so if you are using semaphores or critical sections, this RTOS, it provides the facilities for using such things. Okay, and the last one is the effective management of the multiple state of the CPU, and the internal and external physical or virtual devices also can be managed by using an RTOS. So in this slide we have discussed the advantages of using an RTOS. The first one is that we can execute the user threads in the kernel space, so that they will execute very faster. And the second one is the effective handling of the ISRs, or even an ordinary task, everything, or the IST, everything can be effectively handled. And the most effective thing is the memory management. Okay, the memory will be allocated and deallocated to the process in fixed partitions, and that too will be given on a need basis. And it can effectively schedule the processes. Okay, we have already discussed the scheduling methods, everything. Okay, and now we can move to the RTOS design principles. Okay, when we design an RTOS, it should be designed with the ISRs and the task. Okay, and we should design the ISRs with the shorter code. That is, the length of the code, it should be smaller. and it should be minimal as possible. And we can design the RTOS with the interrupt service threads or the interrupt service task. The ISR, the interrupt service routine, they are uh, written as interrupt service threads. Okay, and we need to design the RTOS as we need to design the task in the RTOS with modularity, with modular design, and it should support the data encapsulation also. Okay, and we should design the task for better and predictable response time control, because in the RTOS we know that it is having the time constraints, because the RTOS, it has the application with real time, hard real time and soft real time constraints. So we need to consider the deadlines, that is we need to consider the time. Okay, and we should also take care of the time spent in the system calls, and it should be kept as minimal as possible. And the next one is that we need to limit the number of tasks and select the appropriate number of tasks to increase the response time to the task, and better control over the shared resource and reduced memory requirement for the stack. That is, we need to reduce the number of tasks, and also we need to reduce the number of functions. That is, we need to include only the necessary functions inside the task. That is for increasing the response time. And also we need to have better control over the shared resource as well as the memory for the stack. And next is we can use the idle CPU time for performing the internal functions. Okay, and we have already said the memory allocation and deallocation. And in the case of an RTOS design, it should be designed such that the task, the ordinary task, it should perform the memory allocation and deallocation. Okay, we know these things. It is very simple topic, and we need to design the RTOS with taking care of the shared resource or data among the task. That is, there will be some processes which share some common resource or common data. So we should take care of such task in the case of an RTOS. Okay, in the case of an RTOS, we can also use the semaphores or the critical section codes for implementing such shared resource. Okay, so these are certain RTOS design principles. Hope you have understood. And now we are moving to the next topic is how to choose an RTOS. So an RTOS, it is chosen according to our requirements. Okay, so when we design an embedded system, we need to choose the RTOS, and there are many factors that need to be considered for the selection of an RTOS, and these factors can be classified as functional or non-functional. Okay, and now we are going to consider the functional requirements. And the first one is the processor support. So it is not necessary that all RTOS it will support all kinds of processor architecture. So we need to consider the processor that we need to support. So it is necessary to ensure that the processor support is effectively done in the case of the RTOS that we have chosen. Okay, and it is according to the application or the system requirement. And the next one is the memory requirement. So we know that the operating system, it requires the RAM or the ROM, and it is actually for holding the operating system files. And we have already told in the first module that we need to store them in the case of and it is stored as a flash memory, right? So it is stored as a flash memory. So we need to make the memory requirement as minimal as possible. Okay, so that is the functional requirement, that the memory requirements, it should be kept minimal as possible. And the next one is the real time capabilities. And we know that the RTOS, it will behave in the real time, that is the real time constraint is there. So we need to consider the RTOS when we choose it. So the scheduling policies, the task or the process scheduling policies, they play an important role in the real-time behavior of an OS. So we need to analyze the real-time capabilities of the OS, and when we choose them, we need to consider the real-time capabilities. Okay. And the next one is the kernel or the interrupt latency. So the latency, the word latency means it is a delay. So there are certain situations in which the kernel of the OS, it may disable certain interrupts while executing certain services. So it may lead to the interrupt latencies. For an embedded system whose response requirement are high, we need to make this latency as minimal as possible. So we need to consider certain OS which has the interrupt latency as small in number. The next one is the inter-process communication and the task synchronization. So this factor is actually the OS kernel dependent. And there are certain kernels which provide many options for this IPC, inter-process communication and task synchronization. So when we choose an RTOS, we should consider this factor also. And the next one is the modularization support. That is when a developer develop the project, he may need to consider the different modules. The different modules may need to be compiled or recompiled. So the RTOS, it should provide the modularization support so that it will be very helpful for the developer. And for example, with the Windows CE, it is an example of a highly modular operating system. And the next one is a support for the networking and communication. The operating system kernel, it should have certain support for all the interfaces that is required for the embedded system. That is, it should support all the networking and the communication facilities or the devices. So it should have the support for all the interfaces. Okay. And the next one is the development language support. We have already said the library files. Okay. And in the case of the library files, it may be necessary and for the running of an embedded system, and it will be written in languages like Java or .NET or C#, everything. So in the case of Java, we have a Java virtual machine customized in the operating system for running the Java applications. And similarly, in the case of .NET, we have a .NET Compact framework. Okay, so we can include these components, that is for a built-in component. Okay, so in order to support these type of applications, we can make this built-in component as part of our RTOS. Okay, so these are the functional requirements. First one is the processor support, memory requirement, the real-time capabilities, the kernel and interrupt latency. In that we need to make the latency as minimal as possible. And the next one is the IPC and task synchronization, the modularization support, and a support for networking and communication, and the language support, the development language support. Okay, and these are the functional requirements. And now we are moving to the non-functional requirements. The first one is the custom developed or off the shelf. The thing is that the requirement of the embedded system, it will be different for each and every system. So we cannot make a complete development of an operating system, or we cannot use the inbuilt operating system. That is, we need to consider all the system requirements, and we need to either customize the already developed operating system. Okay, so sometimes it will be possible to build the required features by customizing an open source operating system. Okay, and the decision on which to select, it is purely dependent on the development cost or the development time and the availability of the skilled resources. Okay, so that is the custom developed or off the shelf. That is, we need to customize an OS according to our requirement. The second one is the cost, the total cost for developing or buying an OS or maintaining it. Okay, so we need to minimize the cost. And the next one is the development and debugging tools availability. So before selecting an operating system, we need to consider the availability of the tools. For if the development and debugging tools are available only, we need to select those RTOS. Okay. And the next one is the ease of use. How easy it is to use the RTOS is another feature. Okay, we know that. And the last one is the after sales. That is, after the sale also, we need to consider all the bugs, and we need to support it. That is after sales. For a commercial embedded RTOS, after sales is in the form of email or on-call services, etc. Okay, for fixing bugs, etc. For fixing bugs or updations or any support for production issues, everything, and it should be analyzed thoroughly. And these are the functional and non-functional requirements. Okay, hope you have understood. And with this much, we are ending this video. Thank you.